To calculate the formal charge for each atom in XeO3, xenon trioxide, let's start with this oxygen here. So we have oxygen, and oxygen's in group 16, sometimes called 6A. We have 6 valence electrons, unbonded, 2, 4, 6 that aren't involved in chemical bonds, 6. And then we're going to take half of the bonded. And these 2 valence electrons right here are the ones involved in a chemical bond. The line represents 2 valence electrons. So we'll put 2 here, and we have 6 minus 1. We end up with a -1 is the formal charge on oxygen. So we'll put a little -1 up here to show that. And these are identical. All the oxygens are the same, so we'll have -1s for all of these. For the xenon, xenon is in group 18, sometimes called 8A, 8 valence electrons, unbonded, just the 2 here. And then for the bonded, we have 2, 4, and then 6 valence electrons, which we'll divide by 2. And we have 8 minus 2 is 6 minus 3, a +3 charge on the xenon. So those are the formal charges for xenon, but they're kind of high. We like to have our formal charges as close to 0 as possible. We also know that xenon is below period 3 on the periodic table. It can have an expanded octet. It can have more than 8 valence electrons. So we can change the Lewis structure here to find one that's more favorable, more likely. So let's try that. So I'm going to take a pair of electrons here and move that to the center and make this a double bond. Next, I'm going to recalculate the formal charges on the oxygen here, and then I'll have to do the xenon in the center as well. So oxygen, we have our 6 valence electrons. We're going to subtract unbonded. We have 2, 4 unbonded now. And then bonded, we made this a double bond, so we have 2, 4. 4 divided by 2. So 6 minus 4 is 2, minus 2, that's 0. So we have a 0 on this oxygen right here. That's kind of nice. Let's try the xenon. We have 8 valence electrons, subtracting the unbonded, 2. And then we're going to subtract the bonded. We have 2, 4, 6, 8. 8 divided by 2. We have 8 minus 2 is 6, minus 4. We have a +2 charge on the xenon. And that's also better. So you can see now, if we took and moved these 2 electrons here to form a double bond, that would become 0, and this would shift to a +1. And then we can move 2 more up here to the center. That would go to 0, and then this would be 0. And then all the atoms in this Lewis structure, in XeO3 Lewis structure, they would be 0. And that's a much more likely Lewis structure. So we used the concept of formal charge to figure out what the best, most likely Lewis structure for XeO3 was. And that's the power of formal charges. They let us look at 2 different Lewis structures and tell us which one is more favorable or more likely. This is Dr. B with the formal charge for XeO3, and thanks for watching.